Well, hi, good morning. Thanks so much for coming and joining me in my shop while I start work on this really beautiful looking Viking radio. Today is October 4th. Just before I get going, since this is the first video in a series, you might be watching my video for the first time, my videos, and so just a little word of warning. I do these essentially live, although they are recorded. And I don't edit them very much, except some rough transitions here and there I'll edit out. So for the most part, you're going to watch me do this without any advanced planning or thinking or anything. So just think of it as a live video and think of yourself as being here with me. That's how I think about it. Number two, if you're a subscriber and you've been watching my daily videos, I try to post every day. I don't always manage that, but I do my best. And you know, I've spent much of my life recently working on a FM receiver and struggling on all kinds of levels with it. That receiver I put away for a while. I'm a little tired of working on it, quite frankly. You're probably tired of watching that too. So my plan is to do this radio, maybe one more before getting back to the FM receiver. That's the plan. I often have plans, but who knows what happens next. Anything can happen in the next hour. So yes, there we go. I got a little bit of paper that came with this radio from the owner, and a nice schematic, nicely printed, nicely done, nicely drafted. I like that already. Viking service information. You notice this was purchased at the T. Eaton Company. So Eaton's was a big deal in Canada for decades and decades and decades. It was the go-to department store. They had a huge mail order system across Canada. Everybody knew Eaton's. Everybody went to Eaton's. And then one day, to my surprise, Eaton's packed it up and disappeared. So that's the story on Eaton's. If you're Canadian, you know the story. If you're Canadian my age, you know the story. So something that grabs my eye right away is caution for service men and service women too. Any service person working with this receiver when it is out of the cabinet should take special care not to come in contact with any ground connections. Okay, so that's a big warning because no doubt this is has no power supply transformer in it. We can verify very quickly by looking at the schematic. You can see the power cord runs right into a series of vacuum tubes. 1, 2, 3, 4, 5, 6 of them. 6 vacuum tubes. And there is no power transformer. And these old radios have non-polarized plugs. The polarization system had not been created in Canada anyway at that time. And the plugs came unpolarized. So this has got a very new looking cord on it. This looks brand new. And it's a polarized plug. So someone has done something to this radio already. Oh! Okay, we know who it is. It's antique. This is something I never do. I've probably done 400 radios or more, and I've never ever attached my name, stuck a sticker on, left a card in, or anything on any of them. I kind of regret it a little bit. Antique radio repair from 1930 to 1960 tube type. Okay, there's his name. I won't repeat it. I don't think this fellow is doing this anymore, but I recognize the name. Thornton. Where's Thornton? There we go. So this would have been much more of a storefront repair operation from 20 years ago, 10 years ago, and probably much earlier. So chances are then this has been fixed up inside. Chances are that guy's done all the capacitors and done everything. So I think my job here is just to make sure this is working properly and performing well, and look for anything that might be out of sorts. So what else do we see on this? We have a string diagram. Actually, that's a pretty complicated string going there. Calibration points on backing plate. Okay, different There's a start point for making sure the pointer is in the right position when the capacitor is all the way, and then a couple other test frequency points across here to do the alignment, but I don't think there's alignment instructions on this page. Okay, I don't see any. Now, this is another note here that's worth noticing here. In order to prevent reception when the set is used as an amplifier with a record player, yeah, there's a phono input here. When used as an amplifier with a record player, the tip of one of the antenna section gang plates has been bent so that this plate shorts out the gang when it is turned to its maximum full in capacity position. Do not remove this short, or radio program and noise will be heard when records are being reproduced through the receiver. This is a fairly common situation with these radios. Not this. This is something I've never seen before. It's probably more common than I've realized. And in other instructions in a similar situation, when you're going to use a radio like this to play a record, the instruction was tune between stations. Tune where there's no radio noise, because the radio is still connected and the phono is just being jammed in ahead of the amplifier. Kind of surprising in a way. Okay, any other little secret notes here we can pick up? Fashion loop consisting of several turns of wire and radiates signal from generator to loop of receiver. Adjust trimmer for maximum output. That's got a star there. Component values. Condensers. Oh, here's an alignment chart here, showing how to do it. Okay, so here's the alignment information. This is a very classic diagram here in terms of drafting and engineering. Down here they have the block for changes. They anticipated when the design was done there'd be and they circulate it past different engineers or build the set and then discover that they could do things better. They make changes on here. Those changes are then listed down here. And that's how you, like the big problem back in the day was you would have this prepared. This might be done as a blueprint. So there could be a number of copies of it. And then changes would be made to it. And there might be a number of copies of those. And then more changes might be made to that. And there might be a number of copies of that made too. And so if you didn't track it on the page here, they would all look essentially the same at a glance. You would start losing control over what's what. Sometimes there was a drawing number. This says J3505. I'm not sure what that is. Often they would put a drawing number here, and the drawing number may have an extension, and they would increment the extension. And if two people had two different versions of the schematic, they would find out pretty quick if they were maybe talking over the telephone or something. So what version have you got? I got version -2, that kind of stuff. Well, some of these problems became even worse when computers came around, trying to keep track of this stuff. In some cases, because it was on paper, and the paper was the thing, there was nothing else, just the paper itself. You could organize it a little bit better. So, but notice there's no changes written in here at all. So, man, they got it bang on right from the start. Another thing about this schematic, while we're looking at it, a little hard to see in the camera maybe, but some of the lines are heavied up. Like this antenna wire is heavied up over these lines. It's drafted heavier. And so you can see that this heaviness is traveling all the way through the radio up here. And that's basically identifying the signal path that the signal is traveling through. That's a common thing. Another thing too is this is a nicely drafted. Everywhere there's a wire connection, there's a big honking dot, and nobody's going to get confused about the size of that dot. So my thumbs up to the people who drafted this. I guess the engineers at Viking. Viking was a brand name, but I think Viking was the company itself. Let's just see. Viking was a brand name for the Eaton's company. So I don't think we know yet who really manufactured this, or whether there really was, at least I don't know, a company called Viking. Okay, now I'm tempted to plug it in and turn it on. It's probably kind of risk-free, but I don't want to do that. Let's just consider this safety situation again. So because of the style and the power supply here, no transformer, this chassis, depending upon which way you plug the plug in, could be live at 120 volts. Now, this one's been, since this is a polarized plug, this can only go in the outlet one way. That can only bring the neutral side in on one of these wires, and that can be handled properly under here, and I'm pretty sure this guy would have done this in such a way that when the set is turned off, there's no voltage on the chassis. But there's no way that just having a polarized plug makes this thing safe. It doesn't. You leave, and kick me if I'm wrong on this, if you leave a set like this plugged in and turned off, that can make the chassis come live. Kind of counterintuitive, isn't it? So I'm not exactly sure if I'm right about that. Excuse me, something else? No metal sticking out. Let's pull this knob off. So the knobs are extended here. Excuse me, and the metal piece that's in here, you can't touch it. These are safety things that were worked out as the years went by. More and more steps were taken to make sure people couldn't get a shock off one of these. You know, these fall off, they disappear. The metal knob's sticking out, somebody's going to grab it. Grab the metal knob, and then put their hand on, or put their foot on the cement floor, or whatever it is. It's extremely dangerous. Extremely dangerous at that point. So I'm going to take the screw out of here, because I'm just worried. A couple things. One, so these pieces of plastic here that you screw into, they become stiff and fragile. See a little piece just fell off there. And if you, often the back is lost, the screws are lost, or something like that. If you put in a screw that's just a little bit too fat into here, crack. So a lot of these you'll find this piece is cracked. Like this one, the front is cracked, but it's not cracked back here. Okay, number two, there's almost certainly, number two? Is this number two? There's almost certainly an antenna back here, we just can't see it. The hint is the back of this radio has rivets here holding this back to the radio. Now you can see it's kind of cracked in here and cracked in there. It's probably been rough handled a few times here and there. It should be out like that, of course. Let's see what it says here. Front of chassis, tuning, volume. This is the order of the tubes, is what they're showing across the back of the radio. Tube locations. Calibration points on backing plate. Okay, same thing again. 550, 600, 950, 1460. That sounds exactly the same. What we saw here. Yeah, same ones. Phono Input. For reproduction of phonograph records, turn dial pointer to extreme left-hand end of dial. Now we did do a little simple test here, which I should have done. I'm guessing this is the tuning side. Okay, so what I'm feeling now is a couple things. One is, how much force do I need to tune it? You see the pointer here? Quite a bit. Quite a bit of force here. That could be for a number of reasons. But that can lead, if there's a lot of force required to tune the radio, you could end up with slippage here. Depends where this tightness is coming from. Okay, and what else? There was something else I had in mind which has just disappeared from my meager brain this morning. Okay, another thing is sometimes the screws coming out the bottom, there's one big one, just a big one there. Some more information down here too. Model RM274. Yeah, it says that on the page too. Cycle AC/DC. Maroon finish, 80 volt amps. Licensed by the Canadian Radio Patents, serial number, and over here it's handwritten. Inspection tag, performance cabinet, final. think the guy actually put his name on there. 865-5354. That sounds like a phone number. And then there's returned, does it say? Read. I think that's a guy's name. When writing for information or parts, quote the model and serial number and inspection stamp number. That could be their business practice of kind of inspecting the inspectors to some degree. Okay, name of the game is to get this guy out of the cabinet here. And pray to goodness we don't want to scratch anything on this radio. It's made it all the way here. Through all those years. Who knows what journey it's been on. And I don't want to be the guy who scratches it up. In fact, working on a radio that's in good shape is actually more nerve-wracking than working on a radio that's in bad shape. If it's really bad, what do you got to lose? If it's really good, you kind of got it. Is it the Hippocratic Oath? Do no harm? That's kind of where I'm at with this. Do no harm. Now, occasionally when you draw these radios out, the pointer is interfered with in some way. So the radio is going to come out, the pointer is going to go with it, the backing plate's going to go with it, this number plate's going to stay at the front here. Yeah, you have to kind of wonder how a radio made it this far without being damaged, without being scratched up. Okay, I see a new capacitor poking out. Now, I'm going to get this cabinet out of here. Good. So usually I like to look these guys over before I turn them on. And I like to turn them on as soon as I can get away with it. As soon as I think it can safely be done. Okay, we don't need the cloth now. There's those marks. They're actually drill holes. They're drilled through. Okay, got it. No surprises here. Oh, yes there is. 3 sections. That raises this up a little bit in terms of radio quality. So we have, here's the gang here. Gang here. There. And there. This is the oscillator. This is the antenna tuner. This capacitor is working against the coil of the antenna. That's why if you have a radio like this and the back is gone, which is quite common, and the antenna has disappeared, you don't even know it was ever there, you're in trouble with a radio that doesn't have its proper antenna. Because this front end won't have any tuning to it. So it'll just degrade the performance of the radio very badly. But in a lot of radios, that's it for the RF tuning, if you like. The cheaper radio. This one, though, has an additional stage of tuning over here. And they're using a transformer to feed the signal from the first tube over to the second tube. A lot of radios wouldn't have this transformer here. They do it a different way. Otherwise, this looks like a very straightforward, fairly simple radio. Okay, so right here, usually there's a lot of interest in a radio between the detector tube and the actual amplifier tube that's going to be powering the speaker. And the interest is various things are done to control the tone quality of the radio. Often the tone control that you can work from the front is located here too. There's no tone control on this radio, just the volume control. So this little network here, excuse me, doing a couple things, but one of it is kind of altering the sound to make it sound good when it comes out the speaker. It says right here, printed circuit. Printed circuit. And what year is this radio? Looks like 1956, I'm guessing, because the word 56 is on this piece of paper here, remember. Not necessarily, but for now we'll pretend it's 1956. Hey, that's when I showed up. Yeah, it's the same age as me. I'm not as good looking as this thing. Okay, well, I work better, I'm sure of it. I lost track of what I was talking about. Okay, so we've got two. This is probably the oscillator, and this is probably the antenna, and this is probably the intermediate. Well, you can see the antenna is actually connected right here. And I see something very unusual here. What is this? What is this little guy here? What is that? So it's right off the antenna. It says your high impedance loop. This looks like any other loop antenna to me. Why they're calling it high impedance loop, I'm not sure. Don't know what that little part is there. Can't say I've ever seen something quite like that. Almost looks like it's popped off something, but no. That's a curious little item there. Something new. Okay. Anything else we can see up above here? There's the light for it. So, how do you power the light? How do you power the light? Where is the light? There it is. So the light is located. That's a little tricky what they've done here. It's got a 35W4. Is there a problem with the drawing? So that's a center tapped heater. And it appears like pin 3, one leg of the heater, is not connected to anything. That doesn't quite make sense. Not sure what's going on here, but there's the pilot light. So, yeah, one of the challenges in a radio that has no transformer, no power supply transformer, and has put all the tubes in series, which by the way means every tube is carrying the same heater current, the same current through all the way through here. Is where do you hook up a 6-volt light? Where do you get 6 volts? So you can't. It's difficult. So one of the tricks that's been played is I guess the tube manufacturer figured this one out. Hey, I can solve the radio designer's problems. That's what tube manufacturers were doing anyway, solving radio designers' problems with better tubes. They simply put a little tap in the heater. So there might be, we don't know, some number of volts dropping across the heater. Here, it's shown properly here actually. Yeah, there's something a little strange about how this is shown here. And that tap is not in the center. You see, it's shown like it's in the center, but it's not really in the center. The tap has been positioned so you can draw 6 volts, considering the current that's going to go in the light, because it's not an insignificant amount of current going in the light bulb. So you can basically tap off 6 volts. Let's put it that way. That's why you see the light do funny things when you first turn the radio on. And people used to think that was some kind of a saving of the filament from the inrush current. I'm not so sure that's particularly true, but what is true is if the light is burned out and that load is not sitting there, this won't be operating the way it was really designed. If something's going to be getting a little more voltage somewhere in here. So it's important to have the light operating. But as for that save the filament because it controls the inrush, I'm not sure about that. But that also makes the light a bit of a test instrument. When you turn the radio on, you expect the light to normally come on fairly bright and then dull way down. And it will stay down for a while. And then it will start coming up again because you actually feed... No, I better not say anymore. Because as much as I've read about this and understood it various times in my life, I tend to get it confused again, just how it works. But they try to sneak the plate voltage through the light bulb. That's very strange looking at this. I think one wire is missing up here. Anyway, as the plates begin to conduct, more current will flow through that light, and you'll see an increase in the light. Usually they put the, not always, but they put the hot tube on the outside of the radio as much as possible. And here it is here. This is the rectifier tube. So rather than stick it in here somewhere, and it makes sense for other reasons too, they have to put it on the outside where it can throw its heat off as much as possible. So this tube gets very hot, and this is the output tube for the drive the speaker. It gets very hot too. So these two hot tubes burn your fingers and generate a lot of heat in this area of the radio. Let's look inside the cabinet for a second. So if you look inside the cabinet, up on the top here, it's pretty hard to see. You can look for evidence of heating, cracking, any kind of discoloration. There's nothing in here at all. So I think this is probably a little used radio. But another way to tell that, you're trying to consider, just how much this radio was used back in its original day. Well, I gotta get the cabinet. You look for fingernail scratches around the knob, or knob wear. This actual knob's been pushed in too far, and it's actually caused some wear here. This is deeply gouged. I can feel this. There's a what do you call that? Relief. There's relief here. You can kind of see it. Volume control, very same. So a lot of these, when people grab them, their fingernails go around the cabinet, especially wooden cabinets. And you can certainly tell when a radio's been really well used. Not so much this one. Can't really tell for sure. So basically it's pretty dust free, pretty clean, pretty nice. Okay, you ready to look underneath? How about the string? String looks original. The string is wrapped quite a few times around here. It certainly looks original. Okay, now we'll go underneath. So I want to tip this one way or the other. So I know when I tip it up, it can become unstable. So I'm looking, where's the heavy stuff? The heavy stuff, heavy stuff. We'll put this end down. It's really stabilized by the big antenna back here, so I don't have to worry too much. Here we go. Dun, 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 dun. Well, it's got a fuse installed. This is something I don't do normally. I know a lot of repair guys will put a fuse in. Big whopping filter capacitors here, 450 volt capacitor, 450 volt capacitor here. Another big electrolytic here. 4 of them, 4 electrolytic capacitors. We'll take a look at the schematic in a minute and see what's up. So a very nice job done here. They've used the cut and loop technique, where you're going to put in a new part. Rather than solder right to the terminal, you just cut the old part out and leave a little bit of wire here. Whoops. Leave a little bit of wire here, and then solder to the wire, which is much easier. Especially this particular terminal has got a fair bit of metal on it. It goes on a rubber grommet. That's something worth noting too, which we'll talk about in a moment. Very nicely done. He's put covers on the wires here. Yeah, very nicely done job. So did he leave any capacitors behind? I'd be stunned if he did. Not this guy. So there's 1, 2, 5, 6. Maybe under here there might be something, but we won't pull it forward to see. I'll look around. Okay. There's got a piece of wire left here. Kind of wonder what this once was. Nothing now. Very nice. So the rubber grommets are a hint. The rubber grommets are a hint that the frame of the capacitor may not be at the same voltage as the chassis. One of the worst shocks I've ever gotten was from a capacitor in a radio like this. And again, it depends which way it's plugged in, whether it's turned on or off. I'm not sure I'm going to be able to study this enough, but you can see the capacitor here. This is the big tuning capacitor, and this is this guy here. And the frame is probably this lower part. Probably this wire represents the frame. Does it go to the chassis? Well, that's a big question, actually. You have to ask it a different way. But no, it comes in, it reaches components. What is happening with the chassis here? So we're looking for the chassis symbol. In this case, they're using the ground type symbol. So this is representing a connection from the guts of the radio to the chassis, the metal chassis. And it's been done, this is very typical, through a large resistor, 330,000 ohm resistor, and 600 volt, 900 volt AC test. I put the value there. And I'll put the value there. So this could be, I don't know, this could be a 0.01 or something of that sort. I'm not too sure. Maybe a little smaller. So the idea here is you could build this whole radio, not have this connection, have the chassis just in there, just a piece of metal in there. It would not be tied to the outlet in any way, and it'd be quite safe in that respect. The difficulty is, a couple difficulties, but the main one is you now have a big chunk of metal in here that can pick up signals, can convey signals from one part of the radio to the other part, and cause a lot of grief that way. So they want to connect it to this basically ground line, if you like, so that signals can't develop in it because it's got a drain. It's literally drained that way. If you connect it right in, now the chassis, under certain circumstances, and maybe not today with the polarized plug, but back when this was made, the chassis would be absolutely live at 120 volts. You could power your vacuum cleaner if you just stuck the wires on the chassis. Well, you could power yourself if you stuck your hand on the chassis like this, and you'd get killed. So in order to make the connection good enough to drain out the problematic signals, yet not make it so good that you can draw a current through your little body because you don't know what's going on, they use this technique. So the thing about this is you can still draw funny little sparks off it. If you take a grounded wire and use it up and down, you get little sparks off of it. And you could also potentially get what's called a brush shock, where you just get a light sensation of getting a shock. Now, in my shop, I'm protected here a number of ways. I won't go into it, but all of them. But one of them is, I'll go. The main one is knowing what you're doing. So I'm about 95% on that. That's the main way you stay safe with a radio like this, is knowing what you're doing. So if you're just watching this, but you're really not into this work, you're really kind of new to it, maybe you got a radio, you're thinking of fixing up in that, you need to read a couple articles, not just one, but a couple articles on the internet on the hot chassis problem. And you need to understand it. And you'll understand it when you reach the point where you realize turning the radio on or off doesn't make it safe. On is not dangerous, off is not safe. You don't really know for sure. It has to do with which way the plug went in. But of course, this radio has a polarized plug, so it's a little different. But a lot of these radios show up on my bench with an unpolarized plug still. So it's kind of important to take a look at this, find where it is, and make sure it's there. But once again, the fellow who did this, a top guy, I'm sure. Nothing too much to worry about, I'm sure, but we'll take a look for it. Another interesting one is, well, then I'm going to plug my phono in. I'm right here. Isn't this grounded, this outside part? And the answer is no, it is not. There's a capacitor there. It's a 1100 volt test. So it's a strong capacitor put here. Same problem. You're going to plug in here, and then the shield of your wire is going to go over to your record player, and now the whole record player is potentially at the same potential as the chassis here. So all these things have been, worked out over the years. You could see as you look at different vintages of radio, different stages of these things taking place, how they're handling it to make things safer and safer. I think by the time you're seeing a radio with extended knobs, they've got all the quote safety features in place. And why have it like this? Why not do something else? Like, for instance, put a transformer in and make a power supply from a transformer. You can then have a completely isolated primary hooked up to your cord, and there's just no way for hydropower or power company power to get into you, because it's just going to the primary, the transformer. Well, the problem with that is nobody would buy this radio, because there's one just like it for $12 less, because it doesn't have the $12 big fat honkin' transformer in it. So to make the radios cheaper, this is what was done. And most radios, in fact, there's a nickname for a radio like this. Unfortunately, it's the it's the All Canadian 5. That's the nickname. You might have heard it misspoken. Some people say it's the All American 5. I'm not sure what's going on there. The All Canadian 5. And that refers to 5 tubes. And when you have 5 tubes, chances are they're connected like this. In fact, these tubes are designed specifically for this kind of radio. So you're going to see over and over the same tubes. Well, not quite. Okay, 12 AT6, it can vary. 12 BA6, 12 BE6, another 12 BA6, and then a 35 C5 and a 35 W4. If you add those numbers up, 12, 12, 12, 12, 35, and 35, you get roughly 115, which is the voltage drop across here. Same current flowing through them all. This is not a 5-tube radio, it's a 6-tube radio. If it were a 5-tube radio, this 35 C5 would be a 50 C5 to compensate for the lack of the other radio voltage or tube voltage drop. Okay dokie, we're pretty close to plugging them in. Why wouldn't we plug them in? There's almost no reason, especially because I have very safe ways of plugging something in. I think I'm going to play the cord out here. So in an old cord, danger right here, danger right here. But this is beautiful, flexible, fantastic. Now on the phono here, am I missing something? So I see this lead. This is the center lead, and then this would be the ground lead, and this is insulated away from the chassis. You look close. There's some kind of brownish material around here. You can see it here. So something has not been done here, or has it? No, it looks like. So it looks like this has been disabled. And by cutting this wire, this is just now a piece of metal here, it's not doing anything. You can't get a shock from it. If you were to go ahead and plug this into something else, there's no chance of conveying a voltage over to it. What would happen if, in the extremely unlikely case that this capacitor shorted? Well, then you could potentially have the outside of the phono jack tied to the line here, which can be tied to one of these two pins, and you're shocked. In this case, what the fella did was he just abandoned this, just cut away that capacitor, and it's done. So I think for people who have a radio like this but aren't operating at a level where they can understand all these things, this is probably a smart move. Just disable it and tell them it doesn't work anymore. Back when this was done, and I'm going to guess this was done 15-20 years ago, I don't really know. Perhaps, you know what, there is an old capacitor left right there. Oh. So this is the capacitor. This is the capacitor. This is probably the capacitor that connected there. Now, how did he get pushed into this position? I don't know. It's a bit of an awkward position. Maybe the wire came up or something. I don't know. But that's probably what that is. So he's left that in. You leave it in for a couple of reasons. One, so someone like me can figure out what he did. Number two, well, it takes effort to cut it out and save the effort, leave it in. That's a pretty small effort. But to some degree, I think it's probably sending a message. I've left this disconnected. No use putting a new capacitor and leaving it disconnected. That's kind of foolish too. Now you can see how he's done the strain relief here. This isn't the best way at all. In fact, oh my gosh. Well, Mr. H or Mr. B. Mr. B. There's the problem with the radio. The power cord has come off. Well, no use plugging this guy in. Now we'll have to figure out where this is really supposed to go. Can't go too far from this position. That's a little odd. But this is not effective strain relief here. Good thing you put a fuse in it, because the wire came off. Maybe that fuse is popped. You can see it goes over to the switch here. One of the things that tends to fail on the old radios is the on-off switch. It can fail on or fail off. What else have we got in here that's worth noting? Well, we're going to have to deal with the power cord problem. He's done a nice job here, shrink sleeve, everything, but not a lot of wire to work with. If I want to cut this, pull it out, put a proper grommet in if I have one. I have to figure out where this goes. Now, this radio looks like I can turn it right upside down, which is really going to be handy. It'll rest on top of this surface and along this. This is pretty stiff still, and this will be airborne, so it won't drag on the tuning. Let's turn it right upside down and see how that works. That's fantastic. Closer look in here. Now, so the white plug is the ground, is the neutral side of the power system. You'd have to guess it maintains right through here. So this is it here. But look at this wire. This side of it is smooth. This side is not. It has some kind of lines on it. That's no accident. That's so you can say, okay, the wide spade is on the marked side. You come all the way up to the other end of the wire, and you can say the marked side. Now, if I got this backwards, the marked side's going into the fuse. Am I right on that? Yeah, this is the smooth side, and this is the marked side. Well, perhaps I have it wrong. But I thought this was the ground. I'll have to. Okay, I don't want to doubt. Oh, so that's how that happened. I don't want to doubt what he did. I'm going to doubt myself first. Is it worth looking in this fuse? Yes, it is. Looks good. Sometimes it's very hard to spot a blown fuse. Looks good. And what is it? What did he put in there? So it's a 3 amp fuse. That's pretty big. 3, looks like 3. It's poorly stamped. 2A 250 volt. That's got to be 2 amps. Nothing else on it. Once in a while I find a car fuse in here. Looks good. 3 amps. Sounds a little high to me. Well, there is a bit of a rush in current when you turn this on. The rush is the tube heaters are cold, so their resistance is low. So it takes a little bit of time for the resistance to come up and the current to go down. That time is on the order of just a fraction of a second or a second or so. So the fuse has to be able to tolerate that. I see a connection here. I'm not so sure it's been soldered. Right here. That looks unsoldered. Yes, it's not soldered. And where is it going? Into the volume control. So it looks like it's the input to the volume control. Because the other side of the volume, the 3 prongs on the volume control, the other side is this black wire. It comes right over to the negatives of the power supply. So it would look like the fellow who did this work also put this in. It looks like that to me. And he's very craftily kind of soldered it in under this metal piece on the chassis. So probably the original capacitor was a fair size. It would have been laying in here, or maybe even laying up here, somewhere where there's a lot of space. It was probably in here. When you take the capacitor out, you win back the space. Then you can use for the new capacitors that are going in, which are usually quite a bit smaller. These are large. Big guys. 450 volts is overkill. The B plus in a radio like this is limited by the fact you don't have a transformer to create the voltage you want. The best you can do is rectify the line voltage, maybe use a full wave rectifier, and the very most you can get out of that would be like 169 volts, because because of the RMS voltage. If you don't know what I'm talking about, you shouldn't be working on radios yet. But meters read RMS, but there is a higher peak. So 120 volts is actually 169 volts in the peak of the wave. So our RMS really relates to the heating effect of the AC signal. So a 169 peak voltage, which would be double that, peak to peak, has the same heating effect as the RMS equivalent of that voltage, which is 117 volts. And that's what we commonly talk about all the time. But that 169 is still there. And so even though it's all, it's a wave going through, or a wave going through, it's there enough that you can use it to charge up a power supply filter capacitor all the way up to that peak. Unless of course you're drawing some current out of it because you're running a radio off of it, you're not going to get 169. You're probably going to end up with 140, 150, something like that. Again, the tubes that are in here are designed for this. They are designed exactly for this. The manufacturers came out with their set of tubes and said, hey guys, use these. Look how simple your radio is going to get if you use these fantastic tubes we've created. That's exactly what was going on. Tubes. We should really call them particle accelerators. It's a lot more exciting to think of them that way. That you have a device in your house that has particle accelerators in it. That it's dealing with atoms and the like. It really is. It's really kind of interesting. Yeah, okay, transistors, sure, everything is particles and whatnot, but a particle accelerator is kind of an exciting way of looking at it. it's almost lucky in a way that transistors weren't fully discovered until later, until the 50s or whenever it was, the late 40s, I guess. Why did I say that? Well, then I wouldn't have tube radios to work on, would I? Because I think if transistors had really been discovered earlier, crystals were discovered. That's pretty weird. I'd like to know how that was discovered, in fact. One more thing to talk about here before I start doing something. That printed circuit. Okay, so there it is there. Now these come on different names. I've never heard this called a printed circuit, but there it is written right in this, right on there, printed circuit. I used to think of a printed circuit as a board with a copper sheet on it, and then it's been manipulated with acid and stuff like that to remove some of the copper, and then you get the trace. And that's kind of the printed circuit board. I believe that's where the word printed comes from. It doesn't sound like it's printed, does it? Maybe it matches some kind of printing thing that was done in some other situation. I don't know. I wouldn't call this a printed circuit board. I can't remember the other name for it just now. Package. I think it had the word package in it. So this was another thing that was made by manufacturers. When it came out, they were saying to the radio designers, look, you don't have to buy all these discrete parts and figure out how to put them all in. Every one of your radios has something like this in it. Just grab this guy and install him. The problem here is that you can have component failures in these. In fact, it happens with some regularity. So inside there is a resistor, capacitor, resistor, and a capacitor, and another capacitor. There's a lot of parts in this one. It's got 1, 2, 3, 4. Did I count that right? I'm counting the number of wires coming out of it. 1, you're crossing the dotted line. 1, 2, 3, 4, 5, 6 wires coming out of it. 1, 2, 3, 4, 5, 6, and 7. 7 wires coming out of it. Okay, we're not going to panic over this yet. I have been lucky in some cases, and I've been able to deduce which component has failed, and it's gone open, and I've been able to just install a replacement component outside of it and leave this whole piece here. Otherwise, if one of these is badly failed, maybe a short, you could find yourself having to recreate this with discrete components. And it can be done, but you're going to have to engineer it into the radio. So that's a problem. This is a problem. Hopefully it's not. Hopefully it's not. That can be a problem. That's what I want to say. So I need to solder this connection and figure out where this wire goes. Let's figure out where the power wire goes. Power wire. So one of them is going right to the switch here. Right to the switch. So there's the switch. So it's the other wire. So the other wire is going potentially right to a terminal on a tube, or what's this out here? Maybe a special terminal. Sometimes, often, tubes have spare terminals, and not all the terminals are used. These are terminals, and it can be quite confusing for people like me or like you if you're doing this kind of work, where you see wires connected to a tube terminal, but actually they're just using it as a spare terminal. That can be confusing. I have a very, very close short back here. I'm going to fix. Very, very close. Right here. That was too close for comfort. It's a long wire from this resistor. That means it's not very rigid. You have short leads, things get rigid. When you have long leads, things are not rigid. Like this. This is nothing rigid about this. So having that wire close there is a little bit scary. Because you can be over here moving something and you don't see that you're moving this wire at the same time. And then kaboomby. Okay, I don't see anything else like that. Okay, back to this. So somewhere obvious it came from. I'm looking for some kind of terminal that's clearly missing its wire, but I don't see one. There's a little piece of something here. That looks like remnants of the old wire. Probably remnants of what was there before this or something. I don't know. There's a red wire in here. Has he replaced a lot of the wires? I don't think so. These are all browned at the ends. They get brown from age. They've been in there a long time. I don't think he probably would do what I would do, which is replace the absolute minimum when it comes to wires. Because once you start into it, like on these radios, the wires can be really stiff. The ones that have a cloth cover tend to be much less stiff than the more modern, just rubber covered ones. And my experience is green wires are the worst. That's not bad. It'd be bad enough that even doing what I'm doing right now would crack it. And the insulation comes off and it doesn't go back on, and it just gets worse from there. You can see here we have a green wire. This is the dark color of green. It's not, the color I'm thinking of is a light color of green. It just seems to me that green wires tend to crack. Look at this. This came out of another radio. This was a tough one to find. This was a shield. It should have to be on my bench though. This is a shielded wire. It ran up against the tube. The tube cooked away on the plastic until it became so brittle it all fractured off, including the insulation on the actual conductor. Well, then the shield, I think the shield corroded away. I think that's what it was in the end. The shield open circuited. And you heat up these wires, components in the plastic will vaporize. And some of it could be sulfur and other bad guys. And they're looking for people. They're looking for people. They're looking for places to react. And so they go right on that copper, right on the plastic, right on this shield, and eat away at it. Because for some reason, sulfur doesn't like being sulfur. It wants to be something else. It likes to be associated with something. Okay, wow, that's a lot of talk. Still don't know where that wire's supposed to go. So there's another piece of wire just hanging out there. Oh, that's the other end of this. Wait a minute, something's not adding up. Something's not adding up. So this capacitor, which is cut free here, is connected to this terminal here. Can you see that? It's a little tough to see in the camera, I know. Let's see if I get a little closer here. Yeah, that capacitor has a lead that goes to this terminal on the tube. Again, this could be a terminal not used. And it's been cut right behind this blue capacitor. Let's move it up. Okay, so moving parts like this capacitor, maybe not this one, but can introduce problems with accidental feedback and oscillations and stuff like that. These capacitors are very different from the coiled up ones, like this. These coiled up ones, they have a sort of self-protection because they're made of two sheets of aluminum separated by something like paper, and then they're coiled up. One of them inevitably ends up on the outside, and that's called the outside foil. And then you can be clever and say to yourself, well, if I'm not careful, that outside foil will become like an antenna. It'll be sensitive to interference and signals. There's some powerful signals floating around in here that you do not want to go places you do not want them to go. So what you do is you say, well, I'll hook the outside foil to the low impedance side of the connection I'm making, and that low impedance will make it very difficult for any kind of signal to build up a meaningful voltage on the outside foil or on the capacitor itself. So there's no outside foil on these to do that with. These are just two plates like this. They're just sticking out there, kind of asking for it to some degree. So now, is that an important problem? I don't know. I mean, I've done a lot of capacitor stuff that can't really say I've ever encountered a real problem with this issue. The radio builders are pretty careful about it. So you can see they mark, like on this old capacitor, the outside foil is marked with those bands. Can you see the bands down there? There's some black. Somehow they mark one end of it, usually with a black band going around it. And they're telling you this is the end that's the outside foil. Better hook this end to a low impedance spot in the circuit. This is probably what was done here. Well, the question is, why isn't this hooked up? Why? It's just cut. It's just cut. Now, maybe he left it and put the replacement in around it, but you know what? I don't see one. I don't see any connection. So we have to investigate this. Find out why he did this. The fellow who worked on this knew what he was doing. I don't think there's any doubt of that. So I got to assume this was done for a reason. Still don't know where to put this wire. So this wire should reach pin number 4 on the rectifier tube. So I know the rectifier tube's out on the end here. Pin number 4, counting 1, 2, 3, 4. This is it right here. 4 is connected solidly to 2. 4 is connected solidly to 2. If I come up here and we look for 2, 5, 7, 3, 4, 6. 2. Chances are 2 is nothing on a 35W4. We're going to take a look here. Pin 2 on a 35W4. Pin 2 on a 35W4. 35Z. There we go. Y. There you go. There we are. 35W4. Pin number 2. So you can see pin number 2. No connection. So that's what they've done here. They've used pin number 2 as a terminal connecting point. And then that wasn't enough for them. They had to also use this. Look, this almost certainly was down here like that. Sure doesn't look like it. The solder here is not fresh in any way. What did he do with this? So I'd like to connect it just for test purposes right now and keep an eye on it while I'm working on it. Okay, so that's that issue. This capacitor. So it's connected on the next tube over. That's the output tube. And it's connected between pins 1. Oh, it's connected across the gap in the tube. That's between 1 and 7, I think, on a 35C5. 1 and 7. There's 1. 1 is the, well, there it is right there. That's the capacitor right there. 1 and 7 is the plate. So between the plate and the cathode is this capacitor. T is 0.022. T means tubular. 0.22. So a 0.02 capacitor. Why would he not have that connected? Because I think that's a pretty important capacitor there. You know, pretty sure this guy's job is to drain out any RF which has managed to get all the way through here. which it shouldn't, but it could. Now we're going to also investigate why are there 4 of these. So if we look in the power supply, which is kind of distributed around here, we see one electrolytic there, one there, one there, and one over here. Let's start with this one. So this one is not really part of the power supply. Look, it's only 25 volts. I doubt you can read that, but only 25 volts. And it's across a fairly small capacitor, 220, and it's hooked up to the cathode. So what this is the cathode resistor. This develops a little bit of voltage, causes the cathode to run a little more positive than it would if this weren't here. If it were right on the ground, it would be 0 relative in here. But this makes the cathode go positive. And what in effect that does is it makes the grid appear negative relative to the cathode. That's the whole idea here. So this is cathode biasing to create the proper bias between the cathode and the grid. It's used all the time. These resistors often work hard. Often they're higher wattage resistors. And they work hard. They carry a fair bit of current. They get warm. These guys go high. They get high, high, high. Double, sometimes double. They can also burn open. But the problem is you've stuck a resistor in the circuit where you're trying to deliver as much power as possible here to the output transformer. But you're going to burn some up here in this resistor. They literally put this in as opposed to other ways to bias the grid. There are other ways, but in this case this is what they've done. So you're going to throw away some of the signal. Well, you can stop that if you bypass it with a capacitor. And really what you're doing is you're raising the ground from a signal point of view up to here. So DC, no, it can't go this way. DC sees the resistor, but the signal thinks it's the ground. That'll cause all the power to develop across here. So that's what that capacitor is there for. Bypass capacitor. That's got to be this one. It's hooked up to the output tube. One side, it's a smaller capacitor. It's a, what's its voltage rating here? It's 450. It's unnecessarily large. You really just need, like it says here, 25 volts or something. They just put a large one in. They could put actually a very small little capacitor in this place here, which is what I would do. I wouldn't spend the big bucks here. So that's that one. Now here's one over here. It's 22 microfarads. These ones are both 50s, two 50s and a 20. So where's the 20? So we look. I'm looking here. This is E50. So it went like this is a T.022, tubular .022, E electrolytic 50. So there's a 50. There's a 50. So these are these two. That leaves this one. It says 20 on it. 150 volt, 20. Another thing about how this is done, and I'm not going to go through the schematic and see that this is really the case, but often you have stages of filtering in these radios. Oops, sorry about that. I'm kind of holding this in a bad way, wasn't I? You have stages of filtering. So you don't actually need the best filtered voltage to drive this tube. As long as the hum is low enough, you can't hear it. So but that same level of hum that would be in this circuit that you cannot hear because it's too low, if you allow that same DC voltage to power these tubes up here, they will amplify that tiny hum. So you need better filtering to drive these tubes. And so often the filters are set up, and that could very well be what this guy is. This guy is an additional filter to help smooth this out. Smooth what out? Let's find it where it goes. Down here. Oh, and there's a voltage, 88 volts, and there's a voltage, 105. Well, this is nowhere near what I was talking about. There's 115 there. 115, that might be AC. What they're showing there. I'm not sure. 88, very low. 105. Well, the tubes are designed for this kind of plate voltage, so good. Wow, okay, I keep finding stuff. Any more to find? So I know where to hook up this wire. I think he missed this capacitor. I think one needs to be installed there. I'm looking to see if he's sneakily installed it. Like often, yeah, it goes there, but those terminals are actually available on the ends of wires somewhere else, and you stick the capacitor somewhere else. Not sure why you would do that. Let's see if that could be the case. So from this terminal there are 3 wires leaving. One is a resistor, one is this capacitor, and the other is this capacitor, and there's no other wire. So I think he just left it out. I think he left it out. So we need to put that in. I'd really like to operate the radio with this the way it is before I do that, because I'm always quite anxious with a radio like this to get it operating to any degree as soon as possible. As soon as I can get something to come out of the speaker, it can just be a hash, and if I affect the antenna, I hear it change, then I know a lot about the condition of the radio. Up until then, you really don't know what's going on in here. Could he have made a mistake and returned this radio defective? Not very likely. Not very likely. But he did. He appears to have done that. Did he do it somewhere else? Not very likely. Not very likely. You really have to study all this stuff to figure out if that happened. When I was talking about the resistor and capacitor to the chassis, here they are. So this isn't quite the right kind of capacitor to put here. There's a chance that you could have 120 volts across this. And that's fine unless this shorts out. If it shorts out, it's not just 120 volts. It's a nuclear power plant pushing on it. And nuclear power plants have a lot of power. They can push enough to make this thing catch fire. So normally, not normally, but often you would find a better capacitor here, and that's part of what they're hinting at in here when they say AC test, 900 volt AC test. 1100 volts, even more over here. The proper kind of capacitor, I'm not going to change that, because these concerns are actually quite remote. The proper capacitor would look more like this. Sometimes these are called safety caps. The idea of these ones is if they fail, they will not catch fire. I don't think that's going to catch fire. I mean, there's no fire concern here, really. But if this were a paper wax capacitor, can't say the same thing, because paper, wax, it's almost designed to catch fire. Well, that's the story there. Okay. So I think I'm going to stop the video, drink some coffee, I'm going to put the capacitor in, hook up this wire, solder that thing, and we're going to turn it on and see what happens. Oh my gosh, it's over an hour already. Okay.